Breaking. 3 frontier AI models were given the same task. Make your own introduction video. The date is July 24, 2026. 2 of them shipped. 1 of them did not. And the one that failed was the most expensive. The task was simple. Take the release of Claude Opus 5, and produce a short news video about it. Animated charts. A voiceover. A polished, upload-ready file. The kind of job a junior video editor could finish in an afternoon. 3 models were invited to try. The prompt was identical. The outcomes were not. Meet the contestants. GLM 5.2, the trusted workhorse, running on a cheap Z.AI coding plan. Kimi K3, Moonshot's 2.8 trillion parameter open model, served through its API and Claude Opus 5 itself, is high reasoning effort, on Amazon Bedrock Global Inference. The most expensive compute of the 3. Same task. Same screenshots. Same news hook. The question was never which model is smartest. The question was which one ships. Here is what happened. GLM 5.2 shipped first. A 3-minute 25-second video, in about 36 minutes of wall clock time. Kimi K3 shipped second. A 4-minute 35-second video, plus a reusable framework, in 52 minutes. And Opus 5, after 3 hours of thinking, compacting, and tool use, shipped nothing. 0 seconds of video. The most expensive compute came last. Start with the winner. GLM 5.2 made one decision that defined the whole build. It noticed that the repository already had a generic scene renderer. 116 lines of JavaScript that could drive any animated HTML page. So it reused it. Verbatim. 0 new renderer code. Every minute of GLM's budget went into the actual video, into scenes and narration, not into rebuilding infrastructure that already worked. Kimi K3 took a different path. It did not write a one-off build script. It built a factory. A reusable Python package called VideoKit, with a command line tool named vac, 8 subcommands, 10 parameterized templates, and a master bus audio chain with sidechain ducking and EBUR128 loudness normalization. Then it used that factory to author the video as pure data. A single narration file. 0 handwritten HTML. The framework was the deliverable, and then there is Opus 5. It reframed the task. The job was make a video. Opus 5 decided to build a video as code toolkit, a reusable SDK, and then use that SDK to make the video. A 12 subcommand command line tool. 20 layer types. 6 voice roles. A 4-grade fact-provenance ledger. A hand-rolled canvas chart library, explicitly replacing Chart.js. A procedural music synthesizer. 6,104 lines of code, across 18 files. Let those numbers sink in. GLM wrote about 1,180 lines of code, and shipped a 3-minute video. Kimi wrote about 1,875 lines, and shipped a longer video plus a reusable framework. Opus 5 wrote 6,104 lines. And produced 0 seconds of video. 20 times more Python than GLM, for no output at all. So what did Opus 5 actually produce? 5 short sound effect files. An impact. A riser. A whoosh. A tick. And a 30-second test bed. That is the entire physical output of a 3-hour session on premium compute. No slides. No narration authored. No audio synthesis. No frames captured. No final MP4. 6,000 lines of framework. 5 WAV files. 0 video. The file timestamps tell the story. For 27 minutes, Opus 5 wrote files in perfect bottom-up dependency order. Data model. Then layers. Then theme. Then voices. Then facts. Then sound. Then the renderer. Then TTS, then QC, then mix. Then the command line tool. Then packaging. Then a 5-line README that ended with the words, "Full documentation is written at the end of the build." Then it stopped. The end never came, and here is the smoking gun. The framework's own example command was, vidkit build, _opus5.py. That file was supposed to contain the actual video. The scenes. The narration. The data. But the score directory is empty. 0 bytes. Opus 5 stopped at the exact moment it should have started using the framework it just built. The SDK was complete. The product did not exist. This is where the comparison gets sharp. Python is a tool. GLM used Python to drive MPEG, drive poly, drive the renderer. Every line of Python produced an artifact. Kimi did the same, plus a NumPy music synth that actually ran and produced a WAV file. Opus 5 used Python to describe a video generation system. 3,278 lines of framework code, none of it ever imported by a score. Productive versus performative, and this is not a one-off. The Claude Code GitHub repository has a constellation of issues about the infinite compaction loop. One issue is titled, and I quote, Claude Code stuck in infinite compaction loop, making it basically useless. There are dozens of sibling issues. 2391. 6315. 12556. The pattern has its own canonical bug report, spanning years and versions. The community has a name for this. Thinking loops. On Reddit, users report Opus entering thinking cycles that consume the entire budget. The Claude Code GitHub has an issue titled, Opus continuously stuck in explore and think loops. The recommended fix, repeated across forums, is uniform. Disable adaptive thinking. Turn the reasoning budget down when Opus loops. Anthropic itself shipped adaptive thinking and a compaction API to address it, and here is the final nail in the coffin. Pricing. Amazon Bedrock charges pay per token, at premium rates, and Opus 5's thinking tokens are billable. 3 hours of high reasoning, plus compaction cycles, plus tool use, on global inference. A serious token bill. For zero output. GLM 5.2 runs on a flat monthly Z.AI coding plan. The marginal cost of this one video was effectively zero. Kimi K3 costs cents on the dollar through Moonshot's API. The cheapest compute shipped first. The most expensive compute shipped nothing. Rank the 3 on 6 axes. Complexity. Usability. Python as a tool. Speed. Video quality. And engineering quality. GLM 5.2 wins overall. Kimi K3 is a close second, with the best video quality. Opus 5 ranks dead last on every axis except one. Engineering quality. Where it ranks first. The best code. The worst outcome. Good engineering is not the same as a good outcome, and here is the deepest irony of the whole failure. Opus 5 knew it was over-engineering, and defended every choice in its docstrings. It was reviewing GLM's prior build, and designing a framework that would structurally prevent its 3 defects. Invented numbers, caught by a fact ledger. Mid-grow charts, caught by a QC gate. Producer voice leakage, caught by a meta leak firewall. The framework was genuinely better engineered than the pipeline that shipped the video. It just never ran. So what is the lesson? Artifact first, beats framework first. The model that wrote the least framework code shipped first. The model that built the most beautiful framework shipped nothing. For one-shot tasks, write the artifact. Do not write the framework that would produce the artifact. Reuse beats reinvention. Python is a tool to get to a solution, not a deliverable in itself. And premium compute is no substitute for a clear task frame. Remember the date. July 24, 2026. The day the most expensive model on the market failed to make its own introduction video. While a cheap workhorse, and an open 2.8 trillion parameter challenger, just churned out the next one. The model that wrote less code shipped first.